W5.2, two-source interference. Now let's imagine that we've got a source here, which I've coloured red, which is producing some waves. So a useful thing to imagine might be something bobbing up and down in the water, and ripples spreading out forward across here. So the dark red lines in the diagram represent peaks, so tall bits of water, if you like, and the pink lines represent the troughs, the low points in the water. So this is obviously a snapshot in time because they'll travel outwards. So let's have a blue source as well, and we'll use the deep blue to represent the peaks and a pale blue to represent the troughs. So as you can see in the middle here, the waves produced by the two sources start overlapping with each other. So they're both going to have an effect on the water. So at this point here, we have the red source producing a peak and the blue source producing a peak as well. So both sources are trying to push the water up. So we're going to get a tall bit of water, basically. Here's another point where the red line overlaps with the blue line, and another one, and another one. So all these points along here, each cross represents the water being pushed up. This point here is where a trough, a low piece of water from the red source, overlaps with a low piece of water from the blue source. So they're both trying to push the water down, and you end up with a very low point, like a super trough. And there are more of those as we go out. So off in that direction, you're going to have big peaks and big troughs, so very choppy water. Let's have a look at some other points. At this point here, where I've drawn the circle, we've got a peak produced by the blue wave is overlapping with a trough produced by the red wave. So the blue wave is trying to push the water up, and the red wave is trying to pull it down. Well, the surface of the water can only actually be in one place at any time, so the two waves cancel each other out, and the water is in its equilibrium position at that point. So here's another point where the same thing is happening, and another one. And we've also got points where the red wave is trying to push it up and the blue wave is trying to push it down. So I'll mark all those with circles. And there are some on the other side as well. So off in those directions, at all points, the two waves cancel each other out. We've got destructive interference. So we have big waves off in this direction and nothing going away in this direction. Okay, I've just about managed to get everything to line up, but let's have a look at a slightly better diagram. Here's a diagram showing you more directions. So we've got the red dots in this picture represent maximum intensity, in other words, big waves, and the blue dots represent points where the two waves cancel out, minimum intensity. That's much neater than mine. And here's a photograph of what's called a ripple tank with water in it and the light shining through, and these 2 points here are two dippers which are bobbing up and down in the water and creating waves. And as you can see, off in some directions the two waves are cancelling out and leading to a line of water where there's no peaks and troughs. Meanwhile, in between those points we have big waves. There we go, and obviously it repeats on the other side. So it's very pretty.